Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Let me introduce myself. My name is Setyoagil Azhar Andartono. I'm from class Meteorology 2B, and here I will do some speech as a keynote speaker, as a meteorology expert from World Meteorological Organization, and the theme is the Meteorological Oscillation, the Indian Ocean Dipole, and the future of hydrometeorological disaster management in Indonesia. So there it is. Ladies and gentlemen, let us begin with a simple fact that the tropics are Earth's heat engine. Indonesia sits at the equator at the intersection of two great oceans, the Indian and the Pacific. And within what meteorologists call the maritime continent, this region acts like a gigantic thermostat for the planet. It is here that the enormous amount of heat and moisture are exchanged between the ocean and the atmosphere, driving weather patterns across the globe. Yet this privilege comes with a cost. Our weather is extremely sensitive to ocean-atmosphere interaction. Small shifts like the sea surface temperature can lead to significant impact on rainfall, storms, and seasonal cycles, which in turn affect agriculture, fisheries, water supplies, health infrastructure, and ultimately the safety and well-being of millions of people. So, what exactly is the MGO? First described by Dr. Ronald Madden and Dr. Paul Julian in 1970s. The Madden-Julian oscillation is the dominant mode of intra-seasonal tropical variability. In simple terms, it is a huge eastward moving pulse of cloud and rainfall that circles the globe along the equator, completing one cycle roughly from every 30 to 60 days. When the MGO is acting over the maritime continent, it can enhance or suppress convection. That is the vertical movement of warm, moist air that forms clouds and storms. This means the MGO can bring unexpected heavy rain during the dry season or delay the onset of the monsoon. For Indonesia, whose agriculture still heavily relies on predictable rainfall patterns, this can spell trouble for rice farmers, plantation workers, and entire supply chains. It can make sudden floods or prolonged dry spells can threaten food security, damage infrastructure, and even contribute to haze and forest fires. Next, let us consider the Indian Ocean Dipole. The IOD is an irregular oscillation of sea surface temperatures in the western and eastern part of the Indian Ocean. When the IOD in a positive phase, the western Indian Ocean becomes warmer than usual, while the waters near Sumatra become cooler. This typically suppresses the rainfall over Indonesia, leading to drought and forest fire risks. Conversely, a negative IOD means warmer waters near Indonesia, enhancing convection and bringing heavier rainfall, sometimes even triggering severe floods and landslides. What is particularly challenging is that the MGO and IOD can interact with each other and with other climate drivers like the El Nino Southern Oscillation or ENSO. Together, they form a complex dance that makes seasonal prediction a formidable scientific challenge. Allow me to illustrate with a few examples. In 2019, Indonesia experienced one of the worst dry seasons in the decades. Millions of hectares land burned, air quality deteriorated, and the economic losses were staggering. That year saw a combination of a strong positive IOD and weak MGO activity that suppressed rain when it was needed the most. In contrast, in early 2020, an active MGO phase contributed to extreme rainfall in Jakarta and surrounding areas, triggering devastating floods that displaced thousands of residents overnight. These cases remind us that weather anomalies are not random. They have drivers that can be monitored, modeled, and communicated if we have the right tools and systems in place. Ladies and gentlemen, we cannot stop the MGO or the IOD. They are natural parts of Earth's climate system, but we can understand them better and use that understanding to protect lives and livelihoods. First, we must strengthen our scientific capacity. This means continued investment in meteorological research, ocean observation networks, and high-resolution numerical models. We need more weather buoys, better satellite coverage, and supercomputers that can handle complex climate simulations. Second, we must improve early warning systems. Forecast information must be timely, accurate, and accessible. But just as important, it must be actionable. Communities must know what to do when a warning is issued. This calls for strong collaboration between scientists, emergency managers, and local leaders. Third, we must build a climate literate society. Schools, universities, and local training centers must be integrate climate education into their curriculum. Farmers should know how to interpret seasonal forecasts. Fishermen should understand ocean current maps. Local government must learn how to plan infrastructure and urban drainage in ways that anticipate extreme rainfall events. Let us now turn to the future. As a member of the World Meteorological Organization community, I am excited by possibilities that modern technology offers. In the coming decade, we will see. The first one is the high-resolution microclimate modeling, providing neighborhood level forecast. And the second one is artificial intelligence or AI that learns from the decades of weather data to detect subtle patterns and predict extreme events earlier than ever. Then we have Internet of Things or IoT devices, rain gauges, river sensors, and weather stations network together and feeding real-time data into cloud-based system. Fourth one, we have remote sensing drones and nanosatellites to monitor remote forests, volcanoes, and coastal areas. The last one, we have customized mobile application delivering hyperlocal alerts in local languages, and we can also hope for more technology in the future. These innovations are not dreams; they are already taking shape. The question is, how do we ensure they reach those who need the most? Technology must be inclusive. It must bridge gaps, not widen them. We must ensure that all small farmers in Papua or fishermen in Maluku have the same access to forecasts as the large plantation owners or shipping companies. Building resilience is not just scientific or technological task. It is also a question of governance, policy, and community trust. We need robust funding for disaster preparedness, not just response. We need local governments that see climate adaptation as a priority. We need international cooperation for data sharing and capacity building. The WMO remains committed to supporting member countries like Indonesia through training, knowledge exchange, and technical assistance. But real success depends on how well we connect these global efforts with local wisdom and community-based action. Ladies and gentlemen, let me conclude with a vision. Imagine Indonesia in the 2045, its centennial years of independence. By then, we hope to see a nation where no farmer plants rice without consulting national rainfall outlook, no village near a river remains unprotected by an early flood warning system, no child loses access to school because a road was away by unanticipated landslides, no forest burns unchecked because fire risks were ignored, and no family loses their livelihood because they were unprepared for the storms and drought that science can help us foresee. This is not an impossible dream. It is a path we can build step by step through science, technology, policy, education, and all above to trust and solidarity among us all. In closing, let me emphasize once more. Weather and climate know no borders. The MGO does not stop at Indonesia's coastline. The IOD does not respect national boundaries. Therefore, our response must also transcend boundaries of institution, sector, and disciplines. I invite all of you to strengthen partnerships, invest in research, expand community outreach, and embrace innovation so that the storms ahead do not become disasters, but lessons we are prepared for. Let us build a future where early warnings means early action, where science saves life, and where every citizen is a guardian of resilience. Thank you for your kind attention. May we continue this conversation beyond this hall, in our laboratories, classroom, policy office, and most importantly, in our communities. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.